Well, I'm running out of rum, so I don't really know what to talk about or think about. I've been trying to imagine what happens, like in little thingies there. Imagine if you could become really, really small, and you'll find yourself so small you're standing on an electron. But then you get even smaller, and the electron becomes comparatively as big as the galaxy, and you're standing on this white field there, and it's just a fraction of 1/1000th the size of an electron. And say that this electron is part of, some kind of thing in the middle of the street that gets hit by a car and gets thrown across the street or something. Well, it's so far away, even if you get destroyed, there's no way you're going to realize what's happening. There's no way you're going to feel the shake. Well, there's probably no way you're going to survive either, because the temperature would probably be the equivalent of 0 on the Kelvin scale, and, well, you're probably going to be unable to breathe because, the oxygen particles will be, so big that there's no way you could take them in. Anyway, so I was in a shopping mall today, and I visited the toilet, and I was thinking of a story. In Japan, when you go to a public toilet, the polite thing to do is to knock on the door, see if there's someone. And so there's this Japanese guy went in the United States, and so he went to a public toilet and knocked on the door, and the guy inside said, "Come in. Just gotta be careful." Anyway, so let's talk about the origin of the universe. Imagine this. Okay? Now, imagine here we would enlarge this thing, this little space, and make it as big as this textbook. Okay? Now, so this page here, well, it's probably going to be a square like that, is this little thingy there that's zoomed in, okay? Now, say you have, right here on the corner, you have a 9. And here another 9. Another 9, another 9. And 9 goes all the way to the end here. And then the whole thing is filled with 9s. And you have a number. And so there's probably going to be like 1,000,000 9s in this little thing. And so you make this longer. So it's kind of like a little strip of paper, and you make it longer, and as you make it longer, the amount of 9s remain the same. And you start stretching it and stretching it and stretching it and stretching it till you're able to pull it and wrap it around my bottle of rum. But then you start wrapping it and pulling it so much that you're wrapping it around the earth, over the mountains and the trees and the buildings and everything, and you're wrapping this little piece of paper over and over again. And so you have the moon, and you're wrapping, and it goes over the moon. And now you think of that famous picture of the Hubble Space Telescope with all the galaxies. And think of the galaxy in that picture that's the furthest away. And that little thin piece of paper is wrapped so many times around the Earth that it goes all the way to that furthest galaxy on the Hubble Space Telescope picture. And so now you have all this little thing with little 9s written on it, on both sides, by the way. And so how many 9s are there in total? Well, all these 9s, they form a number. We're going to call it X. Now, imagine that you have a spaceship that if you have 0.000000001, and the amount of zeros here would be equivalent of x to the power of x. And this is a fraction of a second. And in each fraction of a second here that you have, it will travel, say, y miles. And say that y would be the equivalent of, x to the power of x. And every time here you reach 2 and 3 and 4, all the way to until you get to 1 second. Every time you go up one little thingy there, you add here to the power of y. And y to the power of y becomes z. So the speed at which this spaceship is going is multiplying and multiplying and multiplying. And imagine this ship travels for z amount of years. How far is it going to be? And what is it going to find there? If you find yourself in a little space that's so small that to you a neutron is the size of the galaxy, there is no way to know when you are in a place that small that Irwin Cotler just won the riding of Mount Royal in the federal elections, because it's too far away. And think about, what would this ship see? Say you have a camera on the ship, and the camera is so big that the camera is z miles in diameter. The whole lens of the camera. What kind of picture would it take? What happened z amount of years ago? That time must have existed. If time keeps going forward, it must have kept going backwards as well. Anyway, so I think I'm gonna go sleep now or something.